The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Alrighty, welcome. This is number 17 from Chem 2045's Exam 1, Fall 2009 exam. Number 17 says, when aqueous solutions of lead-2 nitrate and iron-3 chloride are mixed, an ionic solid composed of lead and chloride ions precipitates. Which of the following is the net ionic equation for this reaction? Right, there are three steps to finding a net ionic equation. So the first thing is to find out who the players are in the reaction. So we have that lead nitrate, the iron chloride, giving us some sort of lead chloride solid. Now I've already balanced this equation, and I've balanced each individual molecule, meaning I've put the subscripts down here. How did I determine those subscripts? All I did was I used the crisscross rule, which considers the charges of these two ions. It told me that lead was a Roman numeral 2, which means it has a 2+ charge. And then I look in my chemistry book for polyatomic ions in a nice pretty chart, and it says that nitrate is a -1. So I know that I'm gonna need two nitrates, each carrying a -1 charge, to cancel the total 2+ charge there is. That's why I have a 2 here. You can see though that it's the crisscross rule. There's a 2 here, there must be a 2 there. This is a 1-, there's got to be a 1 there. All right, you do the same thing for all these other species. For all 4 other compounds, you want to make sure that their overall charge is 0. And then finally, you balance. You make sure you have enough leads. Make sure you have enough chlorines in your overall reaction. If you have 6 on this side, you better have 6 on that side. And that's what the coefficients do. Okay, so there's the balance equation. Done. Actually, I lied. Almost done. We need to talk about the physical state of each species. It told me that my first two solutions were aqueous. My solid is the lead chloride. So I'm going to put a solid here. Whenever I drop down to my total ionic equation, this is the part where I break up all the aqueous species. It means that I'm actually taking these two ions, the lead and the nitrate, I'm splitting them apart so that they can float around and play with water. Okay? So as they float around, they each carry their own charge. Lead carries its 2+ charge, and nitrate carries its 1- charge. You split up everybody that was originally aqueous. So notice that lead chloride is solid. Down here, I kept it just the same as lead chloride, without any charges. How do I determine these crazy coefficients now? Well, we take a look at, say, this iron Cl3. I started out with 2 FeCl3s. Here's one, and here's another. So overall, when everything splits up there, how many chloride ions do I have floating out? I have 6. 3 here and 3 there. So that's why I have 6 chloride ions shown here. It's the same idea for the other species, and that's how I get these coefficients. Very good. So this is the total ionic equation. And then finally, the net ionic equation kills off all the spectators, because those were the guys who just were not important in the reaction. They did not play any factor at all. So who did not play a factor? Who started out in the beginning, and then after the reaction happened, they were unchanged. They didn't play a part. That is nitrate. 6 here started out. 6 there ended up. And 2 Fe3+, 2 Fe3+. Finally, I copied down everything that's left, and that's my net ionic equation. I copied it down exactly as I see it, keeping all physical states, charges, and coefficients. Although, here it appears I could reduce these coefficients down. So this, I can divide everything by 3. So this is actually going to be 1, 2, 1. And that is answer choice 5 on this problem.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.